All right. So in this video, we will be using the ratio test for power series to determine the radius of convergence of the power series, which says that the summation of negative 3 raised to n times x minus 5 raised to n all over n times 7 raised to n plus 1 as n where n is equal to 0 um, to infinity. So let us uh, review that in terms of a power series, it, this could also be, uh, or originally, it's the summation of a raised to n multiplied by x minus x sub 0 raised to n, where n is equal to 0 to infinity. So from here, we can determine two important component of a power series: the power series coefficients and the center of the power series. Now, let us recall our ratio test. So, from our discussion, the ratio test says that uh, L is equal to x minus x naught multiplied by the limit of a raised to n plus 1 all over a raised to n as n approaches infinity. So from this ratio test, we can see that we know the value of the center, which in our case it's 5, and also we know the value of the power series coefficients a sub n. So the only things missing in this test is the shifting by 1 of the power series coefficient. So let's do just that. So first, with the power series coefficient, which is equivalent to this part, that's negative 3 raised to n all over n times 7 raised to n plus 1. And then the shifted, which is a sub n plus 1, we just really need to have a plus 1 on all of the n to say that it's shifted by 1. So that's 7 raised to n uh, plus 2. Right? So now let us substitute all of the component in our ratio test. Give us L is equals to x minus 5 multiplied by the limit of a sub n plus 1, which is negative 3 raised to n plus 1 all over n plus 1 raised to 7 raised to n plus 2 all over uh, negative 3 raised to n all over n times 7 raised to n plus 1. And that's the absolute value. Now the limit is n approaches infinity. Now, what we can do is we can first simplify this division of power series coefficients so that we could distribute the limits of n. So we will do just that, but first let us copy um, this one and then multiply by the limit as n approaches infinity. And then in order to make this much easier, or from looking at the denominator, it's going to be negative 3 raised to n plus 1 and divided by negative 3 raised to n. So with that, we can actually uh, minus n on the denominator, or on the power of our numerator, uh, means that negative 3 on the denominator will be cancelled out, and then what we're going to be left with is negative 3 raised to positive 1. And then from the numerator, we have here a common value, which is 7, and then 7 raised to n plus 2, and that's 7 raised to n plus 1. So it's going to be minus n minus 1. So minus n would cancel out the n, and then 2 minus 1 is going to be positive 1. So meaning we will have 7 raised to 1. And take note, that should be absolute value. And then since n plus 1 over n is not common, we're just going to have to rewrite that one. But since it's going to be denominator, so it's going to be the reciprocal. So in reverse, it's going to be n all over n plus 1. Right. Now, taking the limits as n approaches infinity would render this value equal to 1. And then what we're going to have is x minus 5. That's still absolute value since we did not know the value of x. But then we can now evaluate the absolute value here. So the negative 3 here would be rendered invalid, or the absolute value of negative 3 is positive 3. So that's multiplied by 3 over 7. And there, we have the form L is equals to x minus 5 times the absolute value of x minus 5 times 3 over 7. So from here, what we can get is the convergence and divergence of the power series. Now from our statement previously, a series will converge if our ratio test is less than 1. And now let's transpose the constant here to the other side. It means that the series will converge if the absolute value of x minus 5 is less than 7 over 3. Similarly, it will diverge if our ratio test is equated to, or let to be greater than 1. So transposing 3 over 7 on the other side will give us the conclusion that the power series will diverge when the absolute value of x minus 5 is greater than 7 over 3. Now ultimately, our radius of convergence from this information that we got is 7 over 3.